This is 10.8 of geometry. So we're going to talk about probability. In general, here's our probability statement. The probability of some event is the number of favorable outcomes over the number of possible outcomes. So we're going to look at probability length. So if we want to know what's the probability that a point on this whole line is going to land on BC, I'm going to do the length of BC over the length of the whole thing, AD. So, using this timeline up there, it says point H on ST is selected at random. What is the probability that H lies on SR? So we're looking for the probability that, that H lies on SR. So we're going to do the length of SR over the whole thing, ST. So SR, let's count it. It's 1, 2, 3, 4, 5, 6 over the whole thing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 6 over 12 is the same thing as 1/2. So you can write probability 3 different ways. You can write it as 1/2, you can write it as 0.5, or you could rate it as 50%. Any of those would work. So there's a 50% chance that randomly choosing a point, it's going to land on SR. Okay, so a commuter train runs every 25 minutes. If a commuter arrives at the station at a random time, what is the probability that the commuter will have to wait no more than 5 minutes for the train? If we're talking about no more than 5 minutes, we're talking about waiting 5 minutes and less. So I'm going to make my number line just like they did, going up to 25 because that's when the train comes, right? So if the train comes right here, if I show up at 20 or anywhere in between there, I will have to wait no more than 5 minutes. So the probability of waiting no more than 5 minutes, it's not really a short one, is equal to, well, that's 5 over the whole thing, which is 25. If I divide this by 5, divide this by 5, I get 1 over 5. So 1/5, you could also write it as 0.2 or 20%. There's a 20% chance that if I randomly show up at this train station, I will have to wait no more than 5 minutes for the train. Okay, probability of area, pretty similar to the segment 1, too. It's going to be the area of the little piece over the area of the whole piece. So, let's look at this triangle down here in the square. Okay, and we're told that it is a square, so if this is 5 inches, this is also 5 inches, this is also 5 inches, and that's also 5 inches. So we want to know what is the probability that some point T lies in the shaded area. So we're looking for the probability of shaded, so that yellow stuff, out of the hole. Okay, the yellow out of the hole. So 2 options. You can just find the area of the shaded area. If you can do that, that's probably your easiest method. If you don't have a formula to figure out the area of the shaded area, just like they did up here, right? There is no formula for those little curvy triangle things. Then what you need to do is you need to do the area of the whole thing minus the area of the white part. Okay? In this case, we do have an equation. These are each 2.5, right? The area of a triangle is half base times height. So A equals 1/2. Our base is 2.5 here. And the height 5 inches. And we do that on our calculator. We get 6.25 inches squared. So that's this one right here. The other one has exactly the same dimensions, so this one must also be 6.25. So then total, so both triangles, the area is 12.5 inches squared. So that's the area of our shaded area, 12.5 inches squared. And our whole, that's a square. To find the area of a square, we're just going to do 5 times 5, right, side times side. That gives us 25, so 25 goes on the bottom. 12.5 over 25, you can either know that fraction and simplify it. You could type it in your calculator to get a decimal. That ends up being 1/2. So again, it could be 1/2. You can write it as 0.5. You could write it as 50%. Okay. So now we're going to use this target, okay? So we've got this target. Give me a second to draw it. The outside ring is white. The next ring is black. Next ring we get is blue. Next ring is red, and the next ring is yellow. I'm just going to put a Y in there. And we are told in the description up here, the target's diameter, the whole thing across, is 122 centimeters. The radius of the yellow zone is 12.2 centimeters. So this little bit across there, that's 12.2. And then the width of each ring from there is 12.2. So then this ring here, that's also 12.2. And so on. All of those are 12.2. So this is also 12.2. And that chunk would be, and that chunk would be. So let's look at the problem they want us to do down here for our got it problem. What is the probability that an arrow hits the yellow zone? So yellow is the middle, right? So we're going to do yellow out of whole. We're working with circles here. The area formula for our circle, pi r squared. So we're given the radius of our yellow one, right? That was 12.2. So we get area equals pi 12.2 squared, and 12.2 squared is 148.84, and we'll leave pi in our answer, and you'll see why in just a second. So that's the area of our yellow part. And then I need to find the area of the whole thing. Well, our paragraph up here said that the diameter is 122 centimeters. So I need to figure out what the radius is. Remember, the radius is half of that, right? So the radius is 61 centimeters then. So area equals pi 61 squared. Again, I'm going to leave pi in my answer. 61 squared is 3,721. So I stick that on the bottom. Notice now I can cross off these pi's. Pi over pi is just 1. So now all I need to do on my calculator is 148.84 divided by 3,721. And I get 0.04. Remember, we're allowed to leave it as a decimal as one of our answers. If you want that as a percent, that's 4%. So if an arrow goes randomly into this target, so you're not taking into factor any skill or anything, you have a 4% chance of hitting the yellow part. And there's your homework.